Pointers in C. Hello guys, welcome to the channel. Today we are going to cover concepts of pointer. We are not doing coding in today's video. We will just cover the concepts of pointer. Okay. What is pointer? A pointer is a variable that contains the address of another variable. Pointers are much used in C because they are sometimes the only way to express computation, and they also provide more compact and efficient code that cannot be obtained in other ways. Okay. Here we can see this is a variable num and this is point p, which is pointer variable, because it is pointing to another variable and it holds the address of a variable. Address of num variable is 0xbef123 and it holds the address of this variable. Guys, first of all, I'm going to tell you how we store a variable. A variable is stored on a certain location. On a certain location, we have to give we have to store it on a certain location. Our compiler will store when we declare the variable. It is stored on an address Okay. Here I'm going to show you the pictorial representation. This is the pictorial representation. We have to I have taken the boxes to show the content of a variable. Here num has value of 5 and it has address of 0xbf123, and this address has into the box of point p, which is pointer variable, and it holds the address of another variable. What is pointer? Now you can say that pointer is a variable which points to another memory, which points to a memory location, or which points to the address, or which points to a variable. And pointer is a variable which holds the address of another variable. Okay, we use two operators in pointer. First is star or dereferencing operator, ampersand operator. Ampersand means the address of operators, and star operator, dereferencing operator, what it means, value of operator, which when we want the value of any variable, any pointer variable, we use star operator. Okay, but we can use a star operator only on pointer variable, not on a normal variable. Okay, this is integer variable. We cannot use pointer num, and point p is a pointer variable. That's why we have used star point p. Okay, here num has value of 5, point p has address of num. Point p has the value at address of num, and star point p has value of 5. What it means value at this address. What address? Value at the value of point p is this address, and when we use a star means value at this address. Value at this address is 5. That's why we have star point p is equals 5. Here you can print in our C code this is num variable which is 5, and sorry, this is the typo. We will use %p specifier to print the value of this pointer variable, and when we want the value we use pointer point p. Okay, here I've given you the pictorial representation of this pointer variable. Guys, note that in previous slide I have used addresses of variable in hexadecimal, but here I have used in normal decimal numbers. I did so because I want to give you proper understanding. When I use hexadecimal and I will increment it by 1, by 2, by 3, we will do pointer arithmetic, and to understand the pointer arithmetic we should assume that address is decimal number, and I have assumed this is temporary address and not exact same address as on our machine. Okay, I am using this address for only understanding purpose. Okay, here to understand the pointer we should make this box. Inside the box we write value of a variable, and on the upper side of the box we write variable name, and on the below of the box we write address of a variable. Here we have normal variable, here we have integer variable var, which has value of 5 and have address of 1000, and here pointer variable. Why pointer variable? Because it is pointing to var variable. It has the value of address of var variable, means it has value 1000, and this is the address of pvar, which is 2000. Here var equals 5, pvar equals address of var. Here you can put address of var. Here you can put address of var, which is 1000. That is what is written here. And when we use pointer pvar, it will give 5. Pointer pvar means value at pointer pvar means value at address of var. Okay, because it pointing the address of var, and address of var means address of var, ampersand var means address of var. And when we do pointer pvar star pvar, which will equals star, and pvar will be replaced by address of var. And what is address of var? Which is 100, and star 1000, sorry, 1000, and star 1000 equals 5, which will give value of 5. Guys, I hope you understand the pictorial representation of pointers. Do it yourself on your notebook, and do it on your notebook on piece of paper and on your string compiler also, and run the code and see what is happening. Okay, next we are going to see allocating memory to pointers. Pointer variable must point a valid memory location. If it doesn't point to a valid memory location, when we accessing that variable, what it pointing to, we will end up with a segmentation fault error. Okay, memory must allocate to a pointer. Memory must be allocated to a pointer must be deallocated manually. When we allocate some memory to pointer, we must have deallocated it manually by using free function. If we don't deallocate the allocated memory, it is said to leak of memory, and a program having leaking of memory may go out of memory or OEM in case it runs for a very long time. Malloc and free are used to allocate and deallocate the memory respectively. We are going to see malloc and free functions. Memory allocations. Malloc is malloc is the acronym of memory allocation. Is used to allocate a block of memory dynamically. Guys, by using malloc, we allocate memory dynamically. By using array, we used to allocate memory statically. Means in static memory allocation, we have to give the predefined size. In array, we have to give a certain size first. After that, we can assign some values into it. But here, we allocate as much as block, as much as we want, as long as we want. If we want 20 bytes of memory, we can allocate it. If we want 100 bytes of memory, we can allocate it. We can allocate it. We don't give the size at the time. We can give the size at the time of running of program. User can give the desired size, what user wants. Okay. Malloc returns a pointer of type wide. It returns wide type of pointer, and we can cast into any type. It gives default garbage value initially, and it does not initialize memory at execution time. If space is insufficient, returns a null pointer. Here we have taken integer pointer ptr. This is how we allocate memory. Malloc 5 into. In the malloc, we have only one parameter. We have to pass into this malloc function 5, which is size of our block, which is size we want, and size of int means it is the size of our data type, which is int. Here in this case int, we have size of int 4, and we are allocating 5 blocks, means total 5 into 4, which equals 20 bytes of memory will be allocated. Guys, this is the allocation in one line. Here first we typecasted, that is the output, and we have typecasted the return white pointer into int pointer. Now ptr is int pointer, which has 20 bytes of memory allocated. Here you can see it works same as array. We can put pointer ptr plus 1 equals a1. We can assign the value at desired location, and at the end of our code we should deallocate the allocated memory by using free pointer. Free function has one variable, one parameter, which is ptr. We have to pass the pointer variable name that we want to deallocate. Okay, here you can see ptr plus 0, ptr 1, 2, 3, 4, 5, and here at the starting the address is 1000, and in second block it is 1004, in the third block it is 1008, fourth block 1012, and fifth block 1016, and at the last the address is 1020. Kellogg. Kellogg is an acronym of contiguous allocation, used to allocate memory dynamically. It allocates specified number of blocks of memory, very much similar to malloc, but in the malloc we pass only one parameter, but in Kellogg we pass two parameters, size and size of data type. Okay, and it also return white pointer. We typecast it later. We can typecast malloc and Kellogg both into any data type we want. Okay, and it initialize each block with a default value 0. Guys, in malloc it initialize default value, and it in malloc it gives a default garbage value, some garbage value, but in Kellogg it initialize each block with a default value of 0. If space is insufficient, it returns a null pointer, means allocation fails. Here you can see 3 blocks, means 4, 4, 4. 3 into 4, which equals 12 bytes of memory allocated. Realo. When we want to increase the size of our allocated block of memory, we use Realo. Realo function just simply change the previously allocated memory dynamically. What is the parameters? First parameter, Realo also take two parameters. First parameter is ptr, and second is size of new size, means size of data type. Okay, ptr means we are reallocating memory, we are increasing the size of ptr variable. That's why the first parameter is the pointer variable in which we want to reallocate the memory. Okay, you can see that we have a first allocated memory of 20 bytes, 5 into 4, 20 bytes by using malloc, and by using realloc we increase the size to 40, means 10 into 4, which 40. Now we allocated 40 blocks. Okay, guys, note that malloc, Kellogg, and realloc and free are heavy function calls in terms of time. Do not put them into loops. Okay. Pointer arithmetic. What it is? When we do arithmetic operations on pointer, it is called pointer arithmetic. Here we have variable p which is pointer variable p which is pointing to another variable q which has 5, and this is, you can say, this is an array okay. Now we have integer pointer p. Here p plus 1. What it means? P plus 1 means, suppose this is p, forget about for some time about p and q. Consider this is the block of this array block is of p, name p, and we have to do the operation p plus 1. P plus 1 means we are increasing address by 1, but here note that I have taken the address 100, 104, 108, 112, 116, 120. Okay, it will increase size of address by 1, but what is the size of 1? Size of 1 means 4 byte. Okay, because this is integer pointer. Okay, now we are here, p is pointing to 100, and when we increment, it will increment it advanced 100 to 104, and when we take pointer p plus 1, it will give 1 here. Here we have typecasted the address into char. The size of char is 1. Size of char is 1, and we are here 104. We are on 104, and the address will be p plus 1. Size is 1. So the address is 105, and the pointer, if we put pointer variable, it will point the value at address of, it will print the value at address of 105. Okay, what is p plus plus? P plus plus means we increment the address by 1. Suppose we are here 104, and y1 means 4 bytes. We go here. If we put pointer, it will print 2, and now we are at 108, and pointer p means we have value of 2, and we increment 2 by 1, which will give 3. Okay, hope you understand this pointer arithmetic. Okay, okay guys, thanks for watching. If you like the video, please like this video and share with your friends. Subscribe my channel. Thank you guys. Thanks for watching.